cleaner. So, quiz number 7 preview. As always, when we see our sections up at the top, always a good idea to have the notes handy, just in case you get stuck on something so you can kind of see what's going on. So we'll keep those available. Biggest part here in the first section, these first 4 questions, it's as simple as looking at the sign in the middle. These first 2 mention nothing of multiplying, like number 3 happens to. If you FOIL this all out, make a ginormous box, it'll look pretty, but it won't be right. So all I'm doing here in number 1, when it says plus, is combining like terms. I'm going to look for the highest degree terms, and then I'm going to work my way down. So I start going through, I'm like, okay, there's a third, there's a squared, ooh, there's a fourth. Okay, that's the one I want. So I'm starting with x to the 4th. I'm like, okay, let's see, what's next? X to the thirds.
8x to the third and negative 10.
And I got an 8 and a negative 10, which is negative 2x to the 3rd. Notice, I'm not messing with the exponents at all. I'm just adding and combining like terms. So those are set. Let's see here. 7x squared, no other squareds. Okay, so I got a minus 7x squared. X's, I have a positive 1 and a negative 5, negative 4, and then the plus 1 on the end. That's it. Basically, number 1 and number 2 are just going to be combining like terms. But again, it's just the attention to detail of noticing I'm not multiplying here. Now, number 2 isn't quite as simple, but it's still pretty easy. Because on 2, that minus basically is just going to be a negative that I'm going to distribute through, and I'm going to change all the signs on. I would leave the first set of parentheses alone. I'd drop the parentheses, but I'd go ahead and rewrite it. And then I'm just changing the signs on all of my terms in the second set. So the 11 became negative, the negative 8 became positive, positive 6 became negative. And now I'm just doing what I did in number 1, combining like terms, going from the largest degree to the smallest. So let's see, biggest is the third, so negative 11x to the 3rd. And then I got a couple of squared terms. And again, I'm just adding and subtracting coefficients. Don't mess with the exponents on these. I got a 6x. And I've got my 2 constant terms. Greatest to least. After I distribute, no messing with exponents. They're just telling me what to put together. I'm good. Now, for those of you that have just been itching to multiply, now is your chance. Now, on number 3, we talked about 2 different ways you can do this. You can do the old distributive way where you distribute, 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 and then you come down here and you distribute, distribute, distribute. That's fine. But we tended to find with some of you that organizing things a little bit wasn't a bad idea. So if you're comfortable just distributing like we were just talking about there, that's fine. Keep doing that. But if you like the organization of knowing you're actually going to be completing every single part of it, not forgetting part or doing one part twice, this is a good way to go. But again, now that I'm multiplying, now my exponents are going to be changing. 2 times 3 is 6. Add your exponents because you're multiplying. 1 plus 2 is 3. And just keep multiplying that and work your way down. 2 times negative 5 is negative 10. X squared. 2 times 2 is 4x. You can put x to the first if you wanted to. And then I just do the same thing with my bottom row, except I'm just multiplying each of those terms by a negative 3. So again, details. Negative times negative is positive. Negative times positive is negative. And again, the cool thing about this is it even organizes your like terms for you. I just start in the upper left and work my way across. So 6x to the third. There's my like terms with my x squareds, but again, we're just combining like terms now. So negative 10 minus 9 is negative 19. It's still x squared, because we only change it when we're filling the box. 15 and 4 is 19x, and minus 6. And if you did it the distributive way before, you should get the same thing. Now, 4 is a little more of a split decision on how things get done, because we have choices here. Let me kind of box this in here. Two methods we have. We can continue going with things like with the box, or we can use the pattern that we talked about when we were doing Pascal's triangle. So I'll do them both, but if there's one you know for sure that's the way you do it, then just do it your way and don't worry about it. So if I'm doing the box, remember, it means I have 3 of these. I can't just say, oh, it's x cubed plus 27, yay! No. So if I'm going to go the box route, okay, I would have a 2 by 2 box the first time, and I'd be using an x minus 3 down each, because this would represent 2 of my 3 x minus 3 quantities.
So it will be x squared and negative 3x, negative 2x, and 9.
Right, because we're just going to fill in that box, and then just like we did with the bigger box over here, we're going to start in the upper left, and as we move to the right, we combine like terms. Now this isn't my final answer. If this was x minus 3 quantity squared, I'd be done. But I have 3 of them. So I have one more job to do. Okay. I'm going to make another box kind of similar to what we did number 3. Put my last x minus 3 on the short edge, and my answer that I just got from the last one along the top. Now again, if you're more comfortable doing a distributive like you do here, that's okay. So once I have that, now again, I'm multiplying to fill the box. So I'm going to add my exponents. X times negative 6 is negative 6x squared. X times 9 is 9x. Negative 3 times x squared is negative 3x squared. And again, signs and things. Don't get yourself halved to death just with a sign mix-up, or looking at something like 9 times 3 and writing 24. If in doubt, go to the calculator. So once I get here, again, my first term will always be in the upper left, and my like terms will be in the subsequent diagonals. And I get to the answer. Now, the nice thing about this is you're doing the same thing and you're doing something you've done before each time, and you get to the right answer. Bad part is it takes longer and there's more places to make mistakes. So, your other option that we talked about before is using the pattern. Now, I'm just going to put the general pattern up here for a second just as a reminder. The general pattern when we're working with a cubic looks like this. Because we talked about how my A starts up at the third and goes down 1 each time as I go to the right, and how my B starts with nothing and goes up 1 each time as I go to the right. If you've got that, this is the easier way to go, because that'll be my A term and that'll be my B term. So if I was going to do it with the pattern, I'd say, okay, so I'd have x cubed plus 3x squared times negative 3, because that's my B, and I just follow it along. So 3ab squared plus b cubed. And for some of you, that's like me speaking a foreign language, and you want to stick with this, and that's fine. But again, if this is something you're looking at, you're like, oh, okay, I can remember that pattern right there, and then I'm just going to, let's see, negative 3 squared would be 9. That'd be 27x minus 27, and I get the same thing. Either one works. And that's the important thing, that we get to the right answer no matter which way we do it. So you pick a way that works for you and go for it. All right, let's see what else we got playing with here. And if you do run into a question with something, that's okay. You can say something. We can always kind of jump in here with that too. Okay, evaluate the following functions. Find f of negative 3. In other words, this is going to be my x value. Plug that in there and tell me what the answer is.
That would be 12.
So, yep, negative 4 times negative 3 would be 12 plus 3. I'm cleaning up what's inside the absolute value. Don't distribute.
So would it be like multiply then?
And it would. When I get to here, I'm just going to multiply them together. Because even though that 15 comes out as a positive, the negative 2 is outside the absolute value. So I'm not going to get positive 30 as my answer. And it's the same thing even on the next one. Whatever's in the parentheses is what's going to get plugged in for x. So like here to be negative 2 times negative 1 cubed plus 5 times negative 1 squared. Now if you just want to type that into the calculator just as is and get an answer, that's fine. Otherwise, let's see. This would be negative 1 times negative 2 is 2. Negative 1 squared is 1 times 5 is 5. So I believe we're going to get an answer of 7 here. But again, you could always plug that in and double check. Or you could use the store function too if you wanted to do that.
So would you have to what have to do, like multiply first and then exponent, or just exponent?
Exponent trumps multiply every time because it's higher on the order of operations food chain.
Oh, so in the case it would be negative 1 to the third would just be?
Would be negative 1
Oh,
then times the negative 2.
So negative 1 then times
Yep.
2. So basically with 1 and 3, nothing would change, right?
Correct. Now this is one that I was asked a lot about last hour, but this again would be an example if I was confused of saying, now I wonder where I've seen something like this before. So I pull out my handy dandy 6-3 notes and I notice, I have a problem that's pretty similar on that note sheet. So I'm going to kind of take a peek at this and see if I can figure this out this way. Okay, they didn't ask me how much each shirt's selling for, but write a profit function. Okay, how much I take in minus the expenses. I'm selling t-shirts for $12.50 each. Okay, that's like my revenue. So I get $12.50, but I get that per each shirt that I sell. So I have to put my variable term with it because it makes a difference if I sell 100 shirts or if I just sell one. So then, okay, I got to minus whatever expenses I have. They're going to charge me $60 for the design and $4.50 for each shirt, and that each word tells me it gets the X. So I kind of start to see the similarities here a little bit. Now I still need to simplify this. I need to distribute this through, and I'm like, okay, $12.50 minus $4.50 would be 8, and then that negative 60 gets distributed, but it doesn't have an X, so don't combine it with the X's and make it like negative 52X or some crazy thing like that. This would be my profit function, and I just plug in there for X however many shirts I have, and that'll tell me how much money I'm going to make. So when it says find the profit on 125 shirts, once I have my profit function, I just plug that 125 in and subtract, and I see how much money I'd make. But I have to have the profit function right to figure out what the actual profit's going to be.
So if you don't have the profit function right, you won't get the profit.
It's
right?
sort of a double jeopardy problem. Yeah, if you miss the first part, you're going to miss the second part.
Where does that
Because when I distributed here, yeah, I just got that 450 to minus. But again, if any of you are looking later for this, okay, it's no, I'll get there though. It's like, dang it.
So basically 1 through 7, so 1 through 6 is through 6.2, and then 7.
Yeah, but I do bounce around a little bit every once in a while.
Oh.
So I'll try to keep note here of which sections we're hitting as we go. So on the next one, we're hitting our functions and things like that. So now we're back to like what we were doing Friday here. So now we're back into like 7.3. And don't let this funky language complicate things for you at all. When you're looking at this, this is just saying take f of x and add g of x to it. In other words, f of x is 4x squared, and g of x is 2x plus 7. Now, if there were like terms, I'd combine them. But there aren't, so I won't. And I will make mention of this at the start of this. When it says state any domain restrictions, remember, there's two problems. Fractions and even roots, like a square root or a fourth root or something like that. All the other times, there's not going to be any domain restrictions. So you're not going to even have to write anything or worry about it. But those two things you just want to keep in the back of your mind just in case one of them happens to pop up. Okay, so here, and I apologize for my formatting, this is f times g. This is f times g. So
What is this?
So I wasn't trying to fool you, I don't know what happened here. So here, f of x times g of x. So I'm going to multiply f of x times g of x, just like I normally would, where I distribute that through.
So it would be 8x to the third
8x to the third.
and 28x to the
Absolutely. No fractions, no roots, no problems.
like no shirts,
Exactly.
that kind of thing.
Now, the only thing that kind of becomes different here when I get to 10 is now we've got a number to play with. And that actually makes this easier.
Wait, what?
Because here's what I would do, and I've had people do this different ways. I wouldn't bother multiplying them together and then plugging in the -4, even though you could. I'd go ahead and stick the -4 in and just get the answer. So like, for instance here, if I plug in a -4 for x, -4 squared, I'll even do it here so you can see what I'm doing. -4 squared is 16, times 4 is 64. And then for this guy, I'm going to plug in the -4 where x is at. So let's see, -8 plus 7 would be -1. And just multiply them together. Again, same answer either way. So it doesn't matter if you want to multiply the terms, distribute like you did here, and then plug the number in, or just plug the number in at the start. Doesn't matter. But that's what the number's doing.
I thought you can't have a negative. Or is that only-
I can't have like a negative inside a radical. True, I can't have that, but it just is a regular negative number, that's okay. So then 11, kind of separate those. Okay, f divided by g. 4x squared over 2x plus 7. Now, I'm going to put my parentheses around my 2x plus 7 to remind me that I cannot, no, frowny face, whatever, cannot reduce these, because that plus 7 means this is a package deal. If you're going to cancel something here, it's got to be everything, and 7 doesn't cancel into anything. But, red lights, fraction. What's the problem with a fraction? What number can I have in the denominator? What can we not divide by? No.
Seven.
Okay.
Let's see. What can we not divide by? Let's play here. Oh, can I divide by a negative? Yep, still got an answer. Can I divide by a positive? Yeah, still got an answer. Can I divide by a fraction?
No.
Yep, still got an answer. Let's see here. Let's go back and see if we can find this. Hey, look, it's the 7-3 notes. Amazing. Oh, let's see. What division, fraction? Oh, can't equal 0.
Go get a drink.
Because I can't divide by 0. It's undefined. So, I go, okay, this 2x plus 7 can't equal 0. That's what my slash in my equal sign means. But I solve it just like I'd solve any old equation. I'm going to solve for x. So I'd minus the 7 to the other side. And then I'd divide by 2. Okay, so x can't equal negative 7/2. And we talked about how we write this. We want to say every other number works, though. So I say, okay, so from negative infinity up to that number works. And then right after that number, off to positive infinity works. Just like we did when we did the example in 7-3 that I had up a minute ago. The domain idea works the same. Whenever you have a fraction, your domain's going to look like this. It's just going to be what number's in here that I found is basically the only difference it's going to make. All right, let's see what else we got here. F of x and g, what is f minus g of 2? This is kind of like number 10 was up above. I personally think I like doing this, where I literally plug the 2 in, get an answer, then just minus them. So like here, if I plug in the 2 for x, 2 squared is 4. 4 times 4 would be 16 minus 2. Okay, so that'd be 14. And then if I plug it in there, 2 minus 8 is negative 6, and I'm minusing that. Well, we know that when we minus a negative, that becomes plus. So I get my answer of 20 and go right on about my regular business. So you kind of see with this, you're like, okay, I just gotta, take my time with this and life will be all right. So as we get ready to go to the back, I'm trying to give myself a sneak preview here. Okay.
Yeah.
I'll flip it back over for you in a minute here.
Should be really important right now. Since
So I look when I get over to the back and I see some similar issues like we just had as we were working on the front. Again, we're just multiplying, but with that number, it makes life a lot easier. When I plug in 8 here, 3 times 8 is 24, minus 6 is 18, and absolute value is not going to change the fact that's going to be 18. For my q, 8 squared, because I square the x first, so 8 squared is 64, times 2 is 128, minus 3 is 125. I think that's 2250. I'm not hearing any groans, so I'm going to assume I'm right.
might as well.
You're going to double check me?
Yeah,
Okay.
I might as well. You got it.
All right. And then I just do that same last thing on this one. But be careful, they're not always in order P then Q. Worst thing can happen, you start getting things all backwards. So Q of negative 3, negative 3 squared. Okay, so I'd be doing this, which is why we always use parentheses. Negative 3 squared is 9, times 2 is 18, minus 3 would be 15. And then when I stick negative 3 in here, 3 times negative 3 would be negative 9. minus 6 is the absolute value of negative 15, which we know comes out positive. And then I just multiply those two guys together and get my answer that way. So again, just plug the number in. You're basically just doing substitution and then multiplying. Okay, when we get back into our graph mode here, I'm going to go ahead, I'm going to graph. Now for a lot of you, instead of racking your brains trying to remember in this case, now how does all this work? How to just keep life simple? Just come back here and be like, okay, I'm going to type this into the calculator. Okay, I see what the picture looks like, but I want to be a little more accurate, you know, just to be sure. So I'll get the chart up here, and I'll go ahead and I'm going to plug some numbers in. So I see 0, 5, and 1, 4, and negative 1, 4, and 2, 1, and negative 2, 1. That gives me a pretty accurate graph. But then I remember with domain and range, I'm like, well, domain's the easy one, because these graphs are always expanding forever out. So that's always, for these, going to be negative infinity to infinity. Now range, I have to be a little more careful, because it doesn't go up forever, but it does go down forever.
But it comes at a point which is 5 there.
That's right. It goes up to 5 and then it stops. So I can't put positive infinity because that wouldn't be correct, because it doesn't get any higher than 5. And then some of yours favorite. Okay. End behavior. Now, quick explanation again of how this works. Think of it like you would just a regular graph. And then you just think, when you're on X, as you head over to the right here, as this arrow goes forever, you're heading to positive infinity. Again, these are my X values. As I go to the left forever, I'm heading to negative infinity with my X's. When I go up, I'm heading to positive infinity with my Y. And when I head down, I'm heading to negative infinity with my Y. So I'm basically just looking at this graph in here to help me figure out the end behavior. Now as far as my X's go, one of them will always be negative and one will be positive. It doesn't matter which order you put them in. But then you're like, okay, so as X is going left, what's happening to Y? Is it going up or down?
Down.
It's going down. And we just got done saying if Y is heading down,
So it'd be negative.
It's heading to negative infinity. Well, I noticed something else about the graph. Looks like it's going down no matter what. As I go to the right, it's also going down. So both of my f of x's, which is just a fancy mathematical way of saying y, is going to be negative infinity. But again, if you need to draw something out like this, even if you need to write left, right, up, down, and then put the infinities in, that's fine. But don't sit there, you know, smacking your head against the wall the entire time trying to figure out, how am I going to graph? Just type it in. Just keep life simple.
I think I remember seeing in a bathroom someone actually had Banghead here, a poster for Banghead.
I need to find that. Because when I graph this, I notice, okay, where's that Kirby snake guy again?
Serpentine.
Now again, I just am going to get some general points here that fit on my graph that I can easily plot, so I can make something that looks pretty accurate, but it doesn't have to be perfect by any means. Okay, those are the only ones I think are going to fit.
Whoa.
Okay, let me see.
Oh no, I was just thinking like.
Now here, this one kind of makes life easier on me as far as domain and range go, because I see arrows going both directions. Well, domain, I already know what that is.
Range is going down negative infinity and it's going up positive infinity.
Exactly. It's heading both forever down and forever up. So that also is negative infinity to infinity. Now my end behavior, and let me shrink this so we can see our little guide here in the middle again. I have one of each for x.
How do you know where to start? Like
As-
if you go either up or down?
Okay, well, here, like for instance, okay, negative infinity, we know x is heading to the left. So if I just start like in the middle here, like at the y-intercept or something, and I start going left, what's happening to y? It's going down. Okay, so I get that in.
I just like switched those up on accident and then this is.
Yeah, as long as they match up, like if you put the negative infinity down here and put it with it down here, that's okay. And then it's the same thing here. As I'm going to the right for x, what's happening to y? It's going up. And up's just going to be positive infinity. So again, if you need to make the little sketch, that's okay. But that's something you've got to be able to play with. And the rest of this is actually a review of stuff we've had issues with before, because I don't want it to go away until we have it. So, what's my one key here? What do I have to multiply by so I goes away in the denominator, besides just trying to cancel it, which I can't do? 2 minus I in this case, because it's the opposite of whatever sign I see there.
And then just distribute these.
And then basically here, yeah, I'm going to FOIL it. I could do boxes on each of them, whatever it happens to be. So since we've gone box crazy before, I'll just kind of FOIL this out distribute style here. But if you're comfortable with the boxes, do them off to the side. So let's see, 4 times 2, so that'd be 8. 4 times negative I is negative 4I.
Would the later, would the negative 4i just cancel each other out and just be 4?
Nope.
Or no.
The only time that we can say bye-bye to the I is when we have I squared, because that equals negative 1. So we'll be able to do that in a minute with our numerator. And then down here,
4.
I've got 4
And negative 2i.
minus 2I
2i
plus
and then negative
2i
I squared.
and negative I squared. And like we just got done saying, I squared equals negative 1. So basically what I'm telling you is whenever you see I squared, you're just going to change the sign of this. So since it's plus 2,
It's minus 2.
that all goes away, and it's really just minus 2. Not I, just minus 2. Here, since it's like a negative 1 I squared, it changes the sign and becomes positive 1.
So signs switch.
Yeah, because what happens then, for instance, 8 minus 2 is 6.
4 plus 1.
Negative 4 and negative 4 is negative 8. And then here, my plus and minus 2I cancel. So 4 plus 1 is 5. If, like we talked about at the start of class, if this would have been a number that made all 3 of these divisible, like 2 or 4, I'd have to do that. But it doesn't. Unless it goes into all 3, I can't do anymore. I'm done. That's the end.
So even if the number will go into just 2 of them, it would stay the same?
Right. So like if it went into this one but not this one, I can't do that. It has to go into all or nothing. Solving with square roots. Get x squared alone. Before you square root anything. So in this case, add the 8 over.
So it would be 3x squared equals 36.
Do I square root yet?
No.
No.
Divide.
Divide by negative 3. Oh,
Negative.
you know it's coming.
Negative 12.
You know it's coming.
Oh. So square root will be plus or minus. It'll be plus or minus. Pull I out.
Okay. Not only, good catch, not only is it plus or minus, because again, when it's x squared and we're taking the square root, we're going to have that. Remember, if your number breaks down, like 12 does, square root of 4 is 2, pull your I out, like we just had up there, and whichever one doesn't break down stays under the radical. So lots of things there, plus, minus, I, and breaking down your radical. And finally, write the equation of the circle in standard form by completing the square twice. Okay, we're doing each of these guys here on their own. The only thing to remember with this, b divided by 2 and square it. So here, that gives me x squared minus 20x plus 100. Add that 100 to the other side as well. But then I have to do it again with my y's. b divided by 2 squared so I add that 9 to my y's, and I also add it to the other side. So then this stuff adds up to 64. And when I'm going to make my binomials here, so I'm actually in vertex form, remember, you don't have to try and factor this out. Just steal the b divided by 2 number. Again, don't factor it out. Even with a diamond, and it's easy. Just take the b divided by 2 number. And the only thing I have to watch out for now is remembering when I'm doing the center of a circle, that y and that k value are opposites. So I want the opposite of negative 10 for my center.
It will be 10.
Yep, the opposite of positive 3 for my center.
It will be negative 3.
And the square root of what I see as my answer. You know the deal with this. The key is online. All right. The video is going to be online. There's blank copies online. If there are parts you are struggling with, you need to go back and do more of those. So you're ready for this. This is the only thing on the docket for tomorrow and an extra credit sheet. So come in ready to roll. I'll be here after today. I'll be here in the morning tomorrow, but not till probably about 8:20 because I have a meeting.